So thanks a lot, Narayan. I'm Nikhilesh Kumar. I'm one of the co-founder at Vassar Lab. I'm also CEO of Asia Pacific region for Vassar Lab. So a little background on myself. I did my graduation from IIT Kharagpur in instrumentation, and I've also done MBA from ISB Hyderabad. In my earlier days into the career, I spent time in technology, like uh, implementation of sensors, instrumentations, control systems, latest technology, primarily in the sector of energy, oil and gas, manufacturing. And this is like till 2014, and that's when I did my MBA from ISB. And then subsequently, 2015, I met Lakshmi Prasad. He's the founder, like he has already founded Vassar Lab at that time. And with quick round of discussions, I like related to what he was looking forward to do, which is um, he also comes from a technology background. He's from IIT Madras, went to MIT, and started two companies in USA in the technology. So successful tech entrepreneur, and then back to India, was looking forward to bring technology to solve some of the problems in India. And primarily, the problem statement he picked up at that time was all related to primary sectors. So water, agriculture, and cities, even education. And I pretty much felt like uh, when I looked into my experience of 6 years in the technology, which is, if you look in the industry, some of the earlier talk as I was doing, uh, the technology used in the industry is at the latest part. They will make sure that they're using the best of the hardwares, the softwares for efficient management. But that's not the case in water. That wasn't the case in agriculture or even the primary sectors. And I saw a big gap there. I saw a big role that I could have played, and pretty much well connected with what Prasad was thinking of doing it, and joined him in 2015. So what we do at Vassar Lab is, I think today, if I look back 7 years, it's been almost 7 years. We are working with more than 15 government customers. Some of them are at a scale of country. So we work with Ministry of Jal Shakti. We are working with Niti Aayog. We're working with Namami Clean Gange. And then we are working with many state governments. We're also working with some of the river basin authorities. So our solutions, what we have like put through, has been deployed at large scales, country scale, state scale, and pretty much large region problems. What we started with was, initial statement was to help the decision makers in solving the problem in the water, which is uh, water. I mean, like if you go back maybe 50 years, wasn't a problem, but today, water is a sector where it is a big focus. I mean, like when we talk about pollution, so does water becomes also a element, a resource where solution is required given climate change happening. And with climate change, the impact on the availability of water is becoming more stressful. So the problem of water is problem of large surplus and also problem of few. So you'll have times when drought is there, times when flood is there, and the only way to manage such scenarios is to have a system which basically tells you or be able to give you a foresight on what's going to happen, what's now, but what's going to happen. And this is where we started. We built the solution. We call, like we have been calling it, water resource information and management system. Pretty much the user has been government. Why government? Because if you see who manages water, water is being managed by government enterprises. So government department would look after the distribution of water, distribution of dams, flood management, also irrigation management, and then government corporations doing the distributions of the water. And to do that, a large set of data was required. And we saw that data, some of the data was available through the sensors, IoT sensors, bringing data for rainfall, reservoirs. But then there are many other data elements also required. You need to look the entire hydrology. You need to know the rainfall. You need to know water also in the smaller lakes. You need to know the land use, land classification of the entire catchment. So to bring all these solutions together, although we relied on the data coming on real-time stream from IoT sensors, but the gap area is where we started filling it through satellite. And that's our first utilization of satellite happened. And we started using satellite from purposes like flood modeling, where we would use satellite-based understanding of DEM, satellite-based understanding of LULC. Then some of the products that also are real-time in nature from satellite would be rainfall nowcast. Beyond that, we started also using satellite for understanding the water availability. So there are more than 40,000 small water bodies just in Telangana. And so we would have big sensors being put in reservoirs, but you also need to know what's the water available in these smaller water bodies. To do that, you can't put sensors in them, 40,000 sensors. Each sensor costs more than 5 lakh. So it's like a massive amount of infrastructure to be built, and maybe the cost economics doesn't justify. So that's where the question was, can we leverage something else? Can we leverage which is already available in the sky, the satellite-based outcomes? And so that's when we started using optical and SAR data to map in real time the water bodies. So not just water body, but we would say what is a water spread area and what is a volume in the water body. So this is some of the use case in the water. Eventually, with the vision of managing water and providing water security, helping the government provide water security in irrigation, in drinking, in industrial, we saw that we can't solve the problem of water looking only in the water supply side. So the biggest consumer of the water is agriculture. Almost 80% of all the water that is used by human is in irrigation. And the drinking water that we use or in the cities, just a single digit percentage of all our water consumption. So without helping or solving the problem in the agriculture side, we saw that the problem was half solved. And we went into the agriculture management side, which is primarily, again, focused towards water, weather, and the impact of the climate change to the agriculture. So right from what is the right crop that the farmer should sow, looking into the weather pattern, looking into the market demand, looking into how the soil conditions and his distance from the market are there, to when should he sow the crops, what is the right amount of fertilizer he should apply, then what is the crops that he has done, give him a advisory on when the stress would come, give him advisory on pest and disease, and then help the government to also understand what is the overall crop area, what is the overall crop health, what is the overall yield that will happen. So again, a lot of data driven. All these questions require data to come in. These questions require scientific models to be simulated, crop models to be simulated to answer these questions. And a part of that, a large part of that is again coming from satellite. So we use satellite data to map the fields. So we would use machine learning to say, this is the farm boundary. Then we will use machine learning based algorithm to find what is a crop in this particular farm. We would use various algorithms to say what is a crop health, crop yield. So translating all these data into the useful information both to the farmer and to the agriculture. Now, beyond this, we also looked upon the journey towards watershed, so where the water comes from the rain. So can we like the larger impact of climate change is happening not just at the consumptions of the water, but also how the water go through its journey from rain to watershed through the river networks. And we started providing solutions for watershed management, how watershed can be made more resilient to the climate change, how best can we conserve the water in the watersheds in a more scientific manner. So looking into the change in the weather patterns in last 30 years and how it will change in future, how water conservation structure should be put, that we are able to optimize or optimally conserve the water in the best fashion. Some of the solutions that we looked into the city side has been making use of again imagery data, some of them high resolution satellites, some of them drone, where we would help city administration to know things like how is the green cover index in the city, how the green cover index is changing, plantations, where the plantation has happened, and whether the plants are surviving across the next 2 years of the life cycle, how the changes are happening in the city with respect to vertical changes. So, where new structures are coming and are they authorized or not? Where expansions are happening, which is lateral changes, and which are authorized and not authorized. So, these has been some of the applications which we have done from satellite data. So, it has been uh, a journey where being a startup, working with government ecosystem is not very enterprising to begin with. The procurement life cycle working with government is very different. They are long. They are by nature they are always tender oriented through the tenders, or a process is being called, and sometimes it avoids the or rather excludes the startup ecosystem to be part of it. So it has been a journey with a lot of learnings, a lot of challenges. But at the end, when we see that uh, this sector, where technology primarily has been a part of import in India, we have been doing a Make in India effort. We are building softwares, we are building technologies that is solving the problem in water, agriculture, and matters of climate change. And this is not a problem which is just in India. This is a problem which is global in nature. And now we are also looking forward to export these solutions. We want to be part of the India who is solving the global problem. So that has been a short summary of like my motivation, what motivated me to take it up and experience, and what we are doing in Vassar Lab. So use of satellite data, as I said, has been uh, would be a key driver on scaling these solutions. Uh, so when I talked about the water solution, agriculture solution, they have been limited by the availability of the data, which is coming primarily from the sensors network, which is required because they are more quality, more observed data points. However, to scale, the reliance needs to go towards the availability of large scale data sets which are satellite based. And we have been very fortunate that there are very good amount of satellite data today available. We are in the, I think, era where satellites are being more and more launched from the purpose of bringing the data being available. And thanks to some of the space agencies who have made the satellite data freely available for the ecosystem to develop on the use case story, to empower some of the users with these satellite data. So I'll just give example. We are making use of SAR data, which has been pretty much transcending from the water application to agriculture, and I think you guys would know Sentinel-1, what frequency it is available. So this is a very good data source, available at 10-meter resolution with a repeat frequency of 12 days, primarily in the Indian domain. And the use cases are many. We do water body monitoring from there, but we also do crop area estimations. There are other use cases which has not been predominantly used in India, um, which is subsidence, change in the land heights, and on the optical side, again, the freely available data. We make use of freely available data. At the same time, we make use of commercially available data. Um, we use Sentinel-2. Again, it's available at 5-day frequency, 10-meter resolution, pretty good spectrum covering RGB and SWIR band and other infrared bands. Uh, our use case is on crop health, harvesting monitoring, and crop acreage. Again, water body monitoring. However, these are limited from some of the use of Sentinel-1 and 2 or Landsat and other freely available data are primarily in water and agriculture with pixel level informations being extracted. Um, if we want to make use of the satellite data in context of cities, uh, you need a higher resolution data. So drone imagery has been pretty uh, dominating in last 3 to 4 years, where high resolution 4 meters, sub 4 meter, 4 centimeter, sub 4 centimeter imagery would be helping in doing a lot of analytics, creating 3D modeling of the city, creating extractions of the city boundaries, building footprints, uh, plantations, and many more. However, there is a big challenge with drone because it's very operational intensive. It's not scalable, and it takes quite a large amount of time to cover the one city just with drone. So this is where the satellite data, some of the ones which are available today from Planet and Maxars, are very good in helping us. So although they may not help in going sub 10 centimeter region, but 30 centimeter and 1 meter range, the products are available. We are making use of these satellite data, and where they add value beyond the freely available data is when you look into like talk about our mobiles giving us the facial recognition. So there was an era in 2013-14, the facial recognition was there, but it wasn't reliable, right? With the advent of now machine learnings and processing power going into the edge devices, with better neural networks, deep learning coming in, today face learning is like very, very accurate. You hardly see your face recognition going wrong, right? So now image processing or the satellite based imagery is also very similar to the image processing that's happening in the mobile, and technology has pretty much advanced where a lot of features can be extracted from the image. So when we talk about 10-meter resolution, 30-meter resolution satellite data, you cannot extract the features. You can just make sense of spectral parameters and do analytics or even machine learning based some analytics out of it, but the features cannot be extracted. So this is where the high resolution satellite imagery comes in, wherein we are able to identify the building. We are able to identify different kinds of footprints in the city, and using these high resolution imagery at a repeat intervals, let's say every monthly. So one of the use case that we help one of the state government is to identify if the state government lands are being illegally occupied. And the problem with that is if it is already occupied and construction has happened, it becomes difficult affair to evacuate or get the land back to the government. So they would like to understand right before in the early stage when the event of occupation is happening. So we are making use of real-time satellite data. When I say real-time, monthly intervals, and we are making use of deep learning feature extractions to extract and identify this is a land of government, and in this land uh, occupation is happening, and this occupation is of a nature of building or construction something. And then the entire ecosystem and workflow on the software side is built to enable the forces, the officials and ground forces to take corrective action. Now, this particular use case, we are also now seeing that with high resolution satellite data, we can extract a lot of informations. Like for a electricity distribution company, we can extract and tell in this is the route of their transmission lines, and in the route of the transmission line, these are the trees which are nearby and in a vulnerable position to the electricity lines, so that many forest fire happens because of interaction of the trees which can be burned, which has which are burn which can burn because in the heat period has lost the moisture and come in contact with the electricity lines, and then that triggers the fire and that expands in large forest fires. So these are like few applications that we are seeing being able to come because of high resolution satellite data being available. So with satellite data, there are three important pieces that we see making the use case that is meaningful to the user. So although there are satellite data available, but some of the use case, even though you apply the latest technology to extract information, the information is not usable. So what are these parameters? Repeatability is the most important. So what is the repeat frequency? How frequently the satellite data is available? How what is the resolution, the spatial resolution, and what are the bands that are available that provides specific informations from the surface? So that's like about what we are using on the satellite data side.